here with us this evening.
Yeah, thank you, Renee. It's a pleasure to be here. I really do appreciate this opportunity to speak to all of you today about the importance of wetland ecosystems and the ecosystem services that they provide to society. So I think especially given some of the events of last week, I think it's a kind of a timely topic that we're kind of in a unique position here in this region where we're still kind of in our developmental stage, and we have the opportunity to have a positive impact and not make some of the mistakes that other larger metropolitan areas have made, where they have eliminated many of their wetlands, and they're now starting to see some of the consequences for that. So I'm going to talk to you about wetlands as community assets, because at one point in time, wetlands were not really considered worth much. They were considered a source of disease and just wastelands that nothing could be done with. Yeah, we're starting. There's been a lot of advances here in the last several decades on what the important value that wetlands do have, not just ecologically, but to society as well. So let's see. But just to kind of start off real basic to define what a wetland is. Basically, a wetland is going to be an area that is inundated or saturated by surface or groundwater at a frequency and duration sufficient to support a prevalence of vegetation typically adapted for life in that saturated soil. Another way to think of these is transition areas between areas that are permanently wet and permanently dry. They're wetlands. Think about like the edge of a lake, edge of a pond, swampy areas where that water table and that surface water level is constantly going up and down. Some examples of wetlands on a continental scale are going to include river deltas. Think about like where the Mississippi River empties out into the Gulf of Mexico. You often have these areas where when the water level's down, land is exposed, but when the water level's up, these places become inundated. So the vegetation that these areas support are going to be specially adapted to that alternating undulation of the water table. Estuaries are these, places where the sea or rivers meet the sea and ocean, and it kind of backs up into there. You often get these little wet areas depending on the level of the water as it's flowing into these regions. Marshes, these are going to be areas dominated by herbaceous vegetation, often seen along the coast, such as like down in South Louisiana and Mississippi. You have a lot of these marshlands. These are very important areas, not just ecologically, but for also helping mitigate some of the adverse impacts from storm surges during hurricanes and whatnot. And a lot of these fragile ecosystems are being lost at alarming rates. Swamps, these are going to be flooded forests, flooded woodlands. Oftentimes, the water level will go down during the drier months. And so you may have areas that are permanently inundated, but other areas that are just seasonally inundated. So these forested wetland areas or swamps will often support terrestrial vegetation that is adapted to this saturated soil conditions. So bogs and fens, these are going to be your more open wetland areas. And oftentimes the difference, how you differentiate a bog from a fen is the water source and the effect it has on the pH, which can also affect the plant communities in these habitats. And then seasonal wetlands. There are some wetlands, like I mentioned, are not wet or even saturated throughout the year, but they may be saturated 9 months out of the year, and then they dry up during August and September during the dry months. Other areas are saturated during the rainy months, like winter or spring, but then other 6 to 9 months out of the year may not be saturated. So that's why a lot of consultants pay people like myself to go look at these areas, because you can, based on the vegetation that's growing there and the species and other indicators in the soil, that you can tell whether or not the water has been there or has been there long enough to support predominantly hydrophytic vegetation. And so because it's not always obvious when you just go out to an area that area, a few months ago might have been pretty wet. Prairie potholes, these are common up in the northern United States and Canada. These are considered more ephemeral type wetland areas. Is an example of a seasonal type wet area where you have this undulating landscape. And so during the springtime and times of year when it's wet, low areas will fill up with water and produce these little pools of water that are important for migrating waterfowl and for their breeding grounds. So they will travel to these areas and breed. Then when these areas dry up during the drier months, they would typically have to move on to somewhere else. But these are very important ephemeral type wetland areas. So what kind of wetlands do we have here in Northwest Arkansas? Well, we don't have huge wetlands like you would see in the eastern part of the state. Over in eastern Arkansas, the wetlands are typically much larger, but we do have wetlands here. They're often much smaller, and they only cover about 1.5% to 2% of the land coverage in this region. But still, nevertheless, cumulatively, they are very important. We have wet prairies. An example is Woolsey Wet Prairie over there in western Fayetteville by the wastewater treatment plant. We have other mesic prairies. Searles Prairie and Rogers has some mesic areas where that support some various moist soil type vegetation. Here's an example of a wet prairie in Bentonville. This is just south of Southwest 14th Street, but it has some low-lying areas where that groundwater table comes up and supports some herbaceous wetland vegetation. Wet glades, these are going to be areas, where that soil, bedrock or ground, is real close to the soil surface. So often you get that restrictive layer. And then especially in karst topography where you might have a seep or a spring or, water coming, moving through the groundwater, and, that groundwater table stays close to the surface for a long enough period throughout the growing season to support wetland vegetation. There are some wet glades out at Devil's Eyebrow Natural Area in eastern Benton County. So if you go out there in the springtime, oftentimes you're kind of walking around in some soggy soil. There are seeps. This is another example of groundwater where it's kind of coming up from the subterranean region. And, some of these are going to be seasonal. Some of these are going to be more wet year round. This is an example of one in Fayetteville. Here's another seep in Fayetteville near Mount Kessler. Where that groundwater table kind of comes up, and it has a part where it just kind of comes out and flows almost like a spring, but a lot more diffuse and spread out than a spring. So it's still often fed by groundwater. Here's another one in South Washington County, Blackburn Bluffs Preserve. It's near a springy area, but there's also this large area not too far from a spring where it is very, see this groundwater just kind of coming up and creates a seep. And we took this picture after a good rain, and so it was actually had some flow to it. It's very diffuse flow, but you can see the flow flowing through this area. Then you have lacustrine fringes. These are going to be associated with lakes and reservoirs. I mean, think about Beaver Dam. They have to let water out the dam occasionally, and so the water level of the lake might go down. Then you get some rain, that water level goes up. So along the edge of that lake, you're going to have special vegetation that's adapted to that alternating dry, wet conditions. So that's terrestrial vegetation that can handle that moist soil and that saturated soil and even inundation periodically. As opposed to more aquatic species that tend to have floating roots that you might find in more deep water habitats further into the lake. So these are going to be, wetland vegetation is rooted in the soil. And another example of these fringe wetlands are also found around ponds. Here's one in Benton County that I saw earlier this spring. A lot of that brown dead vegetation you see is last year's wetland vegetation. This was taken in early spring before it's really come back. So if you went out there in a couple months, you'd probably see a lot of Ludwigia and other wetland vegetation that would be much more green. So, but you think about these ponds, even farm ponds, the water level during the dry season goes down, you get some rain, it goes up. And so along the edges, you often have these fringe wetlands. Here's an example of a fringe wetland in Fayetteville. In the foreground, you can see last year's Juncus effusus or soft rush. This was taken photo was taken last January or February in the winter time, so it's not very green, but you can see where it's growing in that, saturated and even inundated soil there in the foreground. And in the background, there's American Lotus, which prefers a deeper water habitat. It has some long stems and has floating vegetation. Here's a fringe wetland associated with a pond in Bentonville. You can see that it's on the edge of the pond. The rest of the pond is a little on the outside the right of this picture. But again, that's Juncus effusus or soft brush that you see growing there. And then we have riparian wetlands, again associated with water levels going up and down. These are going to be along the edges of rivers and streams, and these account for most of the wetland acreage here in Northwest Arkansas. So water levels go up after a rain, river levels go up, and depending on the morphology of the stream, the shape of that channel, if the banks or a floodplain is low enough and close enough to the water level, it will flood and create these certain habitats, certain types of environment or conditions that the wetland vegetation is going to be dominant. So here's an example of, this is me standing in a riparian wetland on Cobble Creek, downstream of the Wilson Springs Preserve in Fayetteville. So this is a really important wetland for the people that live in the residential areas and around there. So it's associated, like I said, with Cobble Creek, and it stays pretty inundated. Here's one in Bentonville. This is right across the interstate from my office, Crafton Toll. This is right on at southwest, I believe, 28th Street in Bentonville that you see in the background there. This was taken last week after the floodwaters went down. You can see all that vegetation, how it's been pushed over. And I'll explain a little bit later the importance of this riparian wetland, especially during times like we had last week. But you notice how that floodplain is really close to the water level of the creek, so it's easily flooded when there's high water. All right, so what are ecosystem services? Well, these are going to be the many and varied benefits that the natural environment provides to human society. And so wetlands provide many of these ecosystem services, and I'll go into what these are now. So what about stormwater and flood control? After a heavy rainfall, surface water has got to go somewhere, right? Well, wetlands are considered natural sponges. They can help capture and slow down the flow of surface water, and then gradually release it after peak flood flows have passed. So this helps reduce the frequency and intensity of floods by absorbing and storing this storm water. And it also helps reduce property damage and erosion downstream. So impervious surfaces block rain from soaking into the ground. And since rainwater has to go somewhere, if it's going to the ground, it goes sideways, right? So this is what we call runoff, stormwater runoff. And it either goes directly into the nearest ditch or stream, or is taken to a drain where it then travels to the nearest ditch or stream. So when you have all this area covered by impervious surfaces, it really concentrates the flows and creates what we call these flashy flows. So in urban areas where there's high concentration these impervious surfaces, water flows at higher speeds and at larger quantities. So here's some flash flooding from last week. This is right across the street or across the interstate from my office. And you can see there the flooding that was occurring there. Here's a photo taken by the floodplain manager at the city of Rogers, Christopher Paxton, also of the flash flooding that occurred last week. So all that water should have been soaking into the ground, assuming the ground wasn't saturated. But since we have more parking lots and development, basically it all gets channelized into the creeks and streams. And then when you have heavy rain like we did, it ends up being a large amount flowing here. This increase in stormwater runoff accelerates stream bank erosion downstream and increases turbidity levels of the water. For those of you who don't know what turbidity means, it is just the amount of sediment in the water, suspended sediment. So like murky brown water is going to be high in turbidity, and this has a negative effect on aquatic ecosystems because whenever light is not able to penetrate into the water column, then the algae that are growing in there can't use that light for photosynthesis. And it's through photosynthesis that they produce oxygen that is then exhaled or respired into the water and gives the dissolved oxygen that fish use and other aquatic organisms use to breathe. Not only that, but more turbidity means that more of that soil particles are lodging into the gills of fish, and this has a negative impact on them as well. Whenever their gills get clogged and they can't breathe and they die. So, like I said, wetlands act as natural sponges by capturing and slowing down the flow of surface water and then gradually release it after the peak flood flows have passed. So this helps reduce the frequency and intensity of floods by absorbing and storing significant amounts of stormwater, which reduces property damage and erosion. This is a photo of a stormwater detention wetland in Bentonville by the interstate associated with that, that riparian wetland I showed you a picture of near Southwest 28th Street. Same with this photo I just skipped over a little bit. That's also another stormwater detention wetland. All right, so these the vegetation, the trees, the root mats, and other vegetation helps slow down the speed of the flood waters and distributes that flood water more slowly over the floodplain. This is the same location where I took that other riparian photo. I just turned around and looked downstream, so you can see how all that vegetation has been pushed over by the flood waters. Well, that was also helping to slow down that storm water and spread it out over the floodplain so that it wasn't so intense downstream of that location. So the more of these riparian wetlands that we have, the more that they can do their thing and provide that benefit to society. But when we develop these floodplains and other wetland areas, then we lose that benefit. We lose that ecosystem service. So this combined water storage and breaking action lowers the flood heights and helps reduce erosion and property damage. So wetlands within and downstream of urban areas are going to be particularly valuable. They help counteract that increased rate and volume of surface water that is coming off of the pavements and buildings and other impervious surfaces. So just a little statistic here, the bottomland hardwood riparian wetlands associated with the Mississippi River used to store at least 60 days of floodwaters, but now they estimate that they can only store 12 days of flood water because most of them have been filled or drained. This is a photo I took of the White River National Wildlife Refuge of a nice bald cypress wetland. So this is in the Mississippi River Alluvial Valley. But whenever European colonialists started moving through, they understood that wetland soils are also very fertile. They have a lot of organic matter. Talk briefly about that here in a little bit, but they would drain these wetlands and use them for farmland because of those fertile soils. And so that's how we lost a lot of our larger wetlands in the eastern Arkansas and other parts of the United States. Another important feature that wetlands provide is groundwater and surface water recharge. They help maintain surface water flows during the dry season. So since the water, if it's able to sit in one location long enough, that water is able to sink down into the soil and resupply the groundwater. And oftentimes, a lot of streams, especially perennial streams and intermittent streams, groundwater is a source of the water for those streams. So if you don't have that water, the groundwater feeding it from the bottom, a lot of times those streams, especially the intermittent ones, will dry up. That's why intermittent streams will dry up there in a certain part of the year, because that groundwater table has gone down below the bottom of the stream bank. So wetlands are important as they slowly release stormwater through the surface water, and also while their recharge of groundwater are important to keep water flowing in our local streams, and this helps offset the effects of summer droughts on aquatic species and ecosystems. Not only that, but wetlands are important for water quality. Some people have even decided to start calling them the kidneys of the landscape, and I really like that analogy because it's a really good example of the benefits that they provide. Stormwater runoff often carries contaminants that are harmful to water quality, aquatic ecosystems, and wildlife. Consider the all the vehicles that go through a parking lot and they, drip little bits of, automobile fluids or, petroleum, gas, oil, whatnot. And over time, that stuff kind of builds up on the surface of a parking lot. If you see an empty parking lot, say on a Sunday, when a business may be closed, you'll notice that there's a lot of staining from the automobile fluids. So when you get a heavy rain, that will usually dislodge some of those contaminants, and then that will be carried off into stormwater runoff. And where does it go? It goes to the nearest creek or stream. A common pollutant that you're also going to find in stormwater runoff is sediment. I mentioned erosion and turbidity earlier. So when we have these heavy rains, it's going to dislodge more soil when it impacts, the ground. But it also, through erosion, will start to kick up more sediment and increase turbidity, which has the negative impacts outlined earlier on aquatic ecosystems. So when the flow of surface water is slowed down or contained, that sediment has more time to settle out. So think about these wetlands or stormwater detention ponds. They hold this stormwater. It might be very turbid, but as that water sits there, the sediment with gravity will start to pull it out and it settles down to the bottom. So whenever that stormwater later starts to slowly be released from that wetland, it will often have less sediment in there. Another common pollutant I mentioned was motor oil and automobile fluids. These can contribute significantly to stormwater pollution. And they can be a risk to human health when they get to our drinking water, and they're also harmful to aquatic organisms. Also, pesticides. Think about, people that have their lawns sprayed with whether it be herbicides, fungicides, or people who are having their house treated for termites. Somebody comes around and sprays insecticides around the edge of the house. And you can think about like a neighborhood scale of this type of land use. And then when stormwater comes after a treatment, it's going to carry a lot of these pesticides into the nearest aquatic ecosystems. And these can poison aquatic life. Excess nutrients is another common pollutant we find, whether it be from fertilizer treatments, pet waste, sediment. The largest source I believe of phosphorus is from sediment. And then leaves and grass clippings. And most people don't really think of their grass clippings or leaves as possible pollutants, but they can be sources of excess nutrients when they end up in waterways. So I mentioned, the algae being important for producing dissolved oxygen in the water, but if we have too much nutrients in our waterways, then that creates too much algae, and that can have another adverse effect called eutrophication. Which algae is one of those things you can't have too much, you can't have too little. It's needed, but not in too much quantity in order for it to be a healthy aquatic ecosystem. So the nutrient levels need to be within a healthy range, as well as the sediment levels need to be as low as well. This is an example of a eutrophic water body. These excess nutrients lead to overgrowth of algae. This also reduces the amount of sunlight entering into the water. Not only that, but when the algae dies and microorganisms start to metabolize those little bits of algae, what they do is they consume all the dissolved oxygen in the water while they're metabolizing it. And so that takes up all the dissolved oxygen from the fish and other aquatic organisms that need that to breathe. And so you get these dead zones like in the Gulf of Mexico, these hypoxic zones where all of our fertilizer application from farming in the Mississippi River watershed, eventually what doesn't get used up by plants ends up down there in the Gulf and creates these large algal blooms, which then later create these hypoxic zones, and leads to these large fish kills. And that has a significant negative impact on the fishing industry down there. So polluted stormwater can affect our drinking water resources. So one thing that wetlands have the ability to do is to break down and remove pollutants and contaminants from stormwater, not just by letting sediment settle out, but they can also help the plants in there and the microorganisms in the soil help break down some of the organic contaminants. So also consider plants that use metals as one of their nutrients. There are some plants, especially those with large biomass and woody species, that are going to be a great sink for heavy metals. So as they're growing and sucking up heavy metals that might be contained in stormwater runoff, whether they come from pesticides or from other sources, they're able to prevent those heavy metals from getting into our drinking water supply. Just to give you some examples of some wetland plants and some of the phyto remediation value they provide. Cattails are great for lead. They hold on to that lead around their root zones. Also, they're able to break down the pesticide atrazine and other various types of chlorinated solvents, which is another type of contaminant that's heavy and kind of tends to find these low areas. Arrowhead is really great for breaking down petroleum. Oftentimes, all plants have the ability to facilitate the breakdown of petroleum, but some plants are just better at it than others. Common duckweed, it's able to suck up a lot of chromium and copper. It's also good for breaking down various pesticides like copper sulfate and glyphosate and all that. So one thing, a lot of people might be riding by one of those farm ponds and they see a lot of this duckweed that's taken over. But, one thing to consider is that it is kind of providing some benefit if they're spraying any glyphosate in any of the fields that might drain into that farm pond. Same with wetlands that might have a lot of common duckweed or that pond, that scummy stuff. A lot of people might look at that and think, oh, that's gross, but it is actually helping purify that water and clean it up and make it safer for aquatic ecosystems, as well as for help reduce the costs for our local municipalities when we try to treat our water and make it more potable. Pondweed, really great at sucking up copper. A lot of these plants that are good for remediating heavy metal contents, they're going to produce a lot of biomass. The thing is, to get that biomass out, if you want to remove the copper, you would have to get that pondweed out. But if you have a detention pond, say, and you're just trying to keep that copper from getting past a detention pond, well, you probably want some pondweed in there. You wouldn't necessarily have to think about removing it. It's going to be sucking up anything that comes in there, and as it dies and decomposes, it might deposit it at the bottom of that detention pond. But in the meantime, it is helping out downstream with preventing that copper from getting further downstream. Same thing with certain pesticides, copper sulfate, and the other two listed there that I'm not going to attempt to pronounce. Coontail, another aquatic or wetland species. Really great for breaking down metal lacquer, I'm probably butchering that pesticide name. And then box sedge. This is a really common one that you see in wetland areas. Carex vulpinoida. Vulpinoida, you'll also notice if you're a mammologist or into mammals, is also, I believe, sounds very similar to the family name for foxes. But it is also good at sucking up large amounts of copper. Boglehead sedge has great root zones that are good for breaking down petroleum. Carex stricta or tussock sedge, also great for breaking down petroleum. I mean, a lot of these sedges are going to be good for planting, like say in a rain garden or detention pond, or around the edge of a lake or pond where you might be trying to prevent as much petroleum product from getting into that water body as possible. What happens is a lot of these plants have very fibrous root systems, and like I said, all plants can facilitate the breakdown of petroleum. Some plants are just better at it than others. And the reason that is because a plant, their roots exude compounds that stimulate microbial activity in the root zone. And so a plant that has a big thick root is going to have less of the surface area of the soil underneath it taken up by that root zone. But plants that have more fibrous root systems are going to have a greater surface area or volume of or have a greater surface area associated with the surfaces of the roots. And so a greater volume of that soil is taken up by the root zone, where you have all these little microorganisms that are using petroleum or hydrocarbons as food. So for mild to moderate levels of petroleum contamination, like we typically would see in stormwater runoff, these plants, especially with the fibrous root systems, like a lot of our prairie plants, prairie grasses, and other wetland plants, are really great at facilitating that breakdown versus plants that have thicker roots or tap roots. Juncus effusus or soft rush, another great one to use for breaking down petroleum contained in runoff. Green bulrush, it's another one, great for petroleum. Pale smartweed, this is a common kind of smartweed that we see around here, Persicaria lapathifolia, and it is good at accumulating chromium. Eastern gamma grass, this is thought to be the ancestral plant of our corn, our modern corn that we eat. But it can break down petroleum and also polychlorinated biphenyls, which were once used in all kinds of applications. It's a lubricant with a low heat transfer rate, so it was used a lot in electronics, transformers, and a whole variety of different applications, even outside of electronics. And so those are also very persistent in the environment. And they banned them a few decades ago, but there are still some areas that are contaminated with PCBs. And there are other plant species as well that are great for breaking down PCBs. This also accumulates a large amount of zinc and can help break down some of these pesticides that you see listed there, like chlorpyrifos, chlorophenol. I'm not even going to try. All right, switchgrass. This is not just good for petroleum, but due to its high biomass, is really great for sucking up excess nutrients. So if you have, say, a buffer of switchgrass planted along a waterway near maybe, say, an agricultural field where they might be putting out manure or some other type of fertilizer, and you get a heavy storm, that high biomass, not only will it help capture a lot of that stormwater runoff and sediment and nutrients and help prevent it from getting into the waterway, and so that it settles there within the switchgrass, but it will also make use of a lot of those nutrients and grow very large, thus preventing those nutrients from entering the waterway. This is a great type of grass to be planted along the edge of a farm field where they might be applying fertilizer if they are, that edge is also next to a water body. Bottle brush grass. If anyone's had a baby and has ever used a bottle brush, you might be able to see plainly why they call it that. That seed head looks very much like a bottle brush. And this is one of our wild rye species. It is a cool season grass, so it grows a lot through the cool season and then produces its flower and seed head in the springtime. And so, as opposed to many of our warm season grasses like blue stem and Indian grass, which will grow through the warm season, and then they produce their flowers and seed heads later in the late summer, early fall. But a lot of our warm season and cool season grasses are great for breaking down petroleum. But if you're needing something to put in like a seed mix, and you want to have a mixture of warm and cool season grasses to make sure that you're getting that benefit year round, especially and the latitude we're at, where you have enough warm days in the summertime where you're still going to have some soil microbial activity, this is a great one to include in that seed mix to help break down petroleum. False indigo bush, also called lead plant, because it can pull up a lot of lead as well as copper, and it's also another good one for remediating for nutrients. It has a lot of biomass, and it is woody, so it will take a lot of those nutrients and other compounds and elements and incorporate it into its biomass, and thus removing it from the water. And then black willow, another great one for petroleum and excess nutrients. Again, it grows fast, produces a lot of biomass. It's what we call a phreatophyte, so it has roots that get down deep and like that water. So being fast growing, it's great for that, fast effect on getting pull out some of those contaminants or excess nutrients, or being able to break down some of that petroleum or other organic contaminants like the pesticide bentazone. It also is great for incorporating copper, cadmium, and zinc into its biomass, pulls up a lot of those elements, and so it's good for getting those out of the waterway or the soil. And another one is Sandbar Willow, another one of our native willow species, not quite as common as black willow, but nevertheless also grows here in the Ozarks. And it can also help break down polychlorinated biphenyls, in addition to being good for petroleum and excess nutrients. Eastern cottonwood, also great for petroleum and excess nutrients. It's fast growing, has high biomass, and will incorporate a lot of this stuff into its structure as it pulls it up. And it's also great for just facilitating the breakdown of those petroleum products. And river birch, in addition to excess nutrients, because it's a free ediphyte, it is also good for PCBs and the pesticide bentazone. Willow oak, one of our native willow or oak trees, I'm sorry, it's called willow oak because the leaves resemble willow leaves, but as you can see there's an acorn growing, and that's, I'm not aware of any other tree outside the oak genus that grows acorns. So yeah, this is a willow oak, Quercus phyllus, great for breaking down petroleum and also incorporating excess nutrients into its biomass. It's also a free ediphyte, so this one is also good for both of these purposes. So because of these water purification features, many municipalities around the world and the country have taken to constructing wetlands to help treat their stormwater and wastewater. So this is, there's, benefit to these things. So, and these natural water treatment systems are often going to be less expensive to build than traditional treatment systems, and they have lower expenses associated with their maintenance and operation. Once you get it all settled, if it's designed well, plants are established, often you can just let it do its thing. So here's an example of a stormwater wetland in Fayetteville. You can see there's a lot of that pond scum, or what people would call pond scum, but just think about all the benefits that stuff is providing for the stormwater that flows into it and that it's holding. So, and in the foreground, you can see some Juncus effusus, and in the background, there is some black willow trees. A little bit of black willows in the foreground as well. There's another stormwater detention pond in Bentonville. This was on a slide I used earlier. This is over by the Northwest Medical Center, just off 28th Street. All right, another benefit that wetlands provide is for carbon sequestration. And I'm not going to go too deeply into all this because Dr. Smith is going to have a great presentation later as a third presentation in this series on where she's going to focus exclusively on wetlands and climate change. But just to kind of give you a brief introduction, plants, they breathe in carbon dioxide, and they combine using photosynthesis that carbon dioxide with the H2O. They pull up through the roots, and what you have is they get carbohydrates, and what's left over is O2, which they exhale. So that's how we get oxygen in our atmosphere from photosynthesis. When they take in that carbon, they're incorporating it into their biomass. So when they die and they fall down into the bottom of the wetland or in the inundated soil or inundated water, a lot of that what you call is anoxic condition. So there in the bottom of the water column, there's usually very little oxygen dissolved in the water, and with less oxygen, the microorganisms that break down that like those anoxic environments, they usually metabolize decomposings at a much slower rate than microorganisms that rely on oxygenated or oxic environments. So what we typically see here is in these waterlogged inundated areas is that the rate of decomposition happens much more slowly or much slower than the rate that carbon biomass is being added to the soil. So that's why a lot of wetland soils tend to be very dark and rich in organic matter, and why they would originally drain them for farmland. And so especially when we see wetlands that have like wetland forests, like swamps, not only is there carbon being stored in the soil, it is also being stored in the biomass of the trees. But whereas forests that aren't wet, like a typical upland forest, might be limited by how much carbon it can store because of the limits to the growth of the trees. In wetland forests like swamps, the soils typically are limited by how much soil carbon that they can store. So that histosol soil is what they call a wetland or type soil, is going to keep building up with organic matter over time, and just keep at it, keep sucking in that carbon dioxide. So younger freshwater wetlands and disturbed wetlands can emit carbon until they develop sufficiently enough to where they are able to sequester carbon. But older freshwater wetlands that are going to have these forested environments are typically able to sequester more carbon than they emit. Forested wetlands sequester large amounts of carbon as well in their biomass of the trees. Wildlife habitat. Wetlands also provide food, habitat, and shelter for many species of birds, fish, insects, amphibians, reptiles, and other wildlife. These are some of the most biologically productive ecosystems in the world. Migrating waterfowl, they rely on wetlands in order to rest, eat, and reproduce. And they estimate about a third of the threatened and endangered species in the lower 48 states live only in wetlands. Also, an additional 20% of threatened and endangered species use or inhabit wetlands at some time in their life. So these ecosystems are very important, not just for the more common wildlife that aren't necessarily threatened, but for these threatened and endangered species as well. Also, like I mentioned, groundwater recharge being a benefit of wetlands, and consider in this area that and the karst topography in the caves, we have an endangered fish called the Ozark cave fish. And so groundwater is very important for this cave fish. Without groundwater, it would not have the habitat it needs to survive. And already being limited in population, it could easily go extinct. You know, the more wetlands we have, the more ponds we have, the more groundwater is able to be recharged, and that groundwater can make it down into the caves, versus if we start wiping out our wetlands, and we will no longer have the groundwater recharge that this species needs in order to live. Also, recreation and tourism is another benefit of wetland ecosystems. Because of their high degree of biodiversity, they are often popular places for recreational activities like fishing, hunting, hiking, bird watching, and photography. One of the Society of Wetland Scientists, one of the things that we've done is organized a birding tour back in 2018, as well as a wetland ecology tour at Woolsey Wet Prairie that we invited the public out to come learn about all the different ecological habitat that wetlands provide. We've had one planned for last year, but the pandemic, we decided to put that on hold so that we weren't having contributing to any sort of risk for people, and we wanted to help slow the spread of the COVID virus. So, but here are some photos from some of those events. So here you have some photos in the upper right hand corner, right part of the screen is from the Northwest Arkansas Wetland Ecology Tour. In the upper left hand screen, you have some photos from the people that came out for the Northwest Arkansas Birding Tour. In the lower left hand corner is a native plant hike I led out at Woolsey Wet Prairie, co-led with Joe Neal, who was also doing a bird hike for the Northwest Arkansas Audubon Society. So these are areas where people, especially birders, plant people, and herpetologists, which are people who study snakes and amphibians, do come to geek out on their hobby, or also use these places for research as well, like at Woolsey Wet Prairie. And so these activities help stimulate local economies, bringing visitors to locally owned stores, restaurants, and hotels, which results in additional income for these businesses, as well as tax benefits to the cities. And you think about how many people travel from other parts of the country to eastern Arkansas every year to duck hunt during waterfowl or duck hunting season. You know, this brings a lot of tax benefits and other income to the smaller towns along that part of the state. So some municipalities do capitalize on ecotourism by promoting a canoe trail through their wetlands for the nature lovers that enjoy a truly immersive experience. You see these wetland or canoe trails down in Louisiana. There's also some in central Arkansas as well. Some examples of some of our local parks that have made great use of wetlands. Osage Park, which just opened in Bentonville, has a boardwalk trail through the wetland area there. I do invite you to go out and then walk that boardwalk trail and appreciate that unique habitat, and with especially now that you might have a better understanding of the benefits that that wetland is providing for the residents of Northwest Arkansas. Another example is Woolsey Wet Prairie. I've mentioned this before. It's in Fayetteville. It's a wet prairie. It has sorry. Woolsey Wet Prairie west side is open to the public, and it has one of the highest places highest levels of plant diversity for an area its size. Wilson Springs Preserve, which is owned and managed by the Northwest Arkansas Land Trust, also in Fayetteville, and is accessible by the public. Also, during heavy rains, it does fill up, or it has a lot of soggy, wet areas, and so they have to kind of temporarily close it down to public access just to prevent anybody from getting hurt. But it does have that at the same time, it's providing a lot of stormwater storage and benefits to people in the area and downstream, especially when it comes to erosion control and property damage. Another wetland ecosystem or wetland area, south part of Fayetteville on Dead Horse Mountain. The Watershed Conservation Resource Center is restoring and preserving this area. It's 98 acres south of Huntsville Road along the west fork of the White River at the southeast part of town. They are planning to make this land accessible to visitors. So they're currently working on some restoration efforts right now and trying to get the area at a point to where they are wanting to make it another place with public access. So I do want, once this opens to the public, to encourage you to go out there, kind of see what's going on there. It's going to be a great birding spot from what I hear as well. So wetland losses, this is really the point I want to drive home tonight. Since the 1700s, the U.S. has lost over 50% of its wetland resources. And you can see based on the red here, a lot of that has been in the Mississippi and Ohio River Alluvial Valleys, where we have a lot of agriculture, and a lot of these areas were cleared and wetlands were drained for those agricultural resources. Here's a Google Earth imagery aerial photograph of Northwest Arkansas in 1984. So I would like for you to compare that to 2018. And you can see how much development has occurred during that time. So that's a lot more impervious surfaces that have started to cover the area. And so, back in 1984, if we had a rain like we had last week, we may still likely have some flash flooding, but it probably would not have been at the level we saw last week. So here is Fayetteville and Springdale in 1984 versus now. So you can really see how much development has occurred and how much more the land is covered by concrete and impervious surfaces. Here's Rogers and Bentonville in 1984 versus today, or 2018 at least. So there's been a lot of development that has occurred. But as anyone knows, that this region is still expected to continue growing. We're not done growing. We haven't reached our peak here. So we still have an opportunity to try to preserve the wetlands that are still around. Another thing to consider is the cumulative effect that even the smaller wetlands have in this region. So if we have to, due to development, if they're impacting a small wetland, it's generally a good idea to find some way to mitigate that elsewhere or on site. On site would be preferred. So what can we do as citizens? We can preserve and enhance any wetlands on our own property if you happen to be lucky enough to own a wetland. Support local watershed groups such as the Beaver Watershed Alliance, the Illinois River Watershed Partnership, and Ozark Water Watch. A lot of these groups have volunteer days. We're doing all kinds of things that improve our watershed, and a lot of them are also involved in funding the rain garden projects in the watershed. Rain gardens, basically, they act as miniature small wetlands, and I'll talk a little bit more about those here shortly. We can implement more green infrastructure on your own property, whether these be rain gardens, bioswales, filter strips, rain barrels, that sort of thing. Anything to help slow down, soak up, and store that stormwater runoff. Advocate for wetland protection at your planning commission meetings and other public forums. Educating the public is very important. A lot of people don't realize the benefit that we are receiving from these wetland ecosystems. What can local governments do? Well, they can establish stream and wetland protection programs such as protection ordinances or zoning regulations that include wetland conservancy. Establish expert regulatory boards or advisory committees for wetlands, or even adapt local real estate tax incentives for people that have a wet area on the property. You see a lot of that over in the eastern United States. With real estate tax incentives for preserving or conserving or even enhancing wetland on the property. They can preserve and protect wetlands on local government lands, such as parks, greenways, and in forest areas. You know, the Osage Park in Bentonville, I mean, that's a wonderful use of a wetland. If a city were to acquire a wetland, you know, you can definitely use it for, give it public access and make it a nice little area that people can go and enjoy, especially people that enjoy watching birds and waterfowl. Restore and construct wetlands for pollution control, stormwater, for parks and recreation. You know, these don't have to be large wetland areas. They can be something on the scale of, say, detention pond or a rain garden or a stormwater wetland, something that's just meant to capture and hold stormwater. You know, implement green infrastructure and natural infrastructure projects on city property. These would all be examples of green infrastructure and natural infrastructure. So, what is green infrastructure? Just to give you a definition, these are engineered systems such as rain gardens, bioswales, green roofs, etc., that mimic the functions of natural systems such as wetlands. Here's an example of a rain garden over at the University of Arkansas near Agri Park. Benefits of green infrastructure is that they provide localized flood control, just on a much smaller scale than a wetland ecosystem would, but they still can help, especially whenever they're implemented, you know, on a cumulative scale. They can help reduce flow intensity of creeks during storm events. They also help improve water quality by filtering that storm water, increasing infiltration and recharging groundwater supplies. And depending on the species that are growing in that, you know, rain garden or bioswale, they'll provide other benefits for water quality as well, like I discussed earlier. So here's an example of a rain garden bioswale that Craft and Toll recently designed. This is at Hickory Creek Marina, and that's Beaver Lake there in the background. So what you see there in the foreground is the rain garden, and we have a bioswale, which whenever the rain garden fills up, that bioswale will help transfer that water to Beaver Lake, but at a slower rate. And also the edges of it will be vegetated. Right now you see the plants have just been put in after I took this photo. And so they haven't quite gotten to the level that they need to be at before it will be fully functional the way we have designed it. But yeah, here is that rain garden. And I included some of the species discussed earlier, especially the ones that had the phytoremediation benefits, or in case you're not aware, phytoremediation is the use of plants to break down environmental contaminants, remediate environmental mediums such as soil or water. And this is the bioswale portion. Like I said, if we get so much rainwater to where it tops out, then it will start to flow down this bioswale at a slower rate than it would have, which might have caused more erosion, and hopefully will have more time to infiltrate into the soil. And also spend more time in that soil means that the plants will have more of a chance to purify that stormwater before it reaches our drinking water source with Beaver Lake. So natural infrastructure approaches include forest, floodplain and wetland protection, watershed restoration, wetland restoration, and conservation easements. So green infrastructure, when it's utilized in combination with natural infrastructure, are often referred to as these hybrid systems. And these provide a lot of benefits that we don't really typically get with our traditional hardened infrastructure. Natural infrastructure, such as healthy wetlands, can provide many of the same benefits of traditional man-made infrastructure, but at a much lower overall investment and maintenance cost. So unlike traditional human-made structures, a well-designed and maintained natural infrastructure project will not depreciate like an artificial system, where you might start to get concrete breaking down due to weathering, freezing, and whatnot. But in fact, it might actually increase in value over time, especially as those plants really get established and plant communities go through their natural successionary stages. They also produce many ancillary benefits such as wildlife habitat, carbon sequestration, water filtration, groundwater storage, and floodwater attenuation. Just to give a little plug for the Society of Wetland Scientists, we are a professional organization of wetland scientists representing members of the private and consulting community, such as myself, or people in academia and whatnot, people that are involved in all kinds of aspects of wetland science. And our mission is to promote understanding, conservation, protection, restoration, science-based management, and sustainability of wetlands. And it's going to put my contact information on here. Anybody, you're welcome to reach out to me by email. That's also the direct line to my office if you have any questions. And I'm also happy to provide a copy of my slides if anyone might be interested. So with that, I will give a big ta-da and end my presentation. Thank you.
Thank you, Eric. I love that final slide too. Ta-da! Thank you. That was great. And I'm going to watch the chat for any questions, but I will start off with one or two. But what is there anything that landowners can do, or does it make sense for landowners that do have, you know, ponds or other wetland type areas? Can they plant some of these plants that you featured in your presentation? And if so, where do you acquire those plants?
Yeah, I mean, it depends on the species. There are some native plant nurseries that you can get these from, as well as state sources like the Missouri Department of Conservation. I'd really recommend you go to look at the resource guide for Grow Native, which is an educational part of the Missouri Prairie Foundation, but they have a list of all kinds of native plant sources in the region. You know, you could also, if you're, you know, so inclined, collect seeds yourself and get these things established yourself. There are some plants that are going to be easier to do that than others. Other plants you're probably going to see growing out there anyway, you know, depending on what it is. Or some of these plants that we typically consider, you know, noxious, you know, just want to kind of point out that they do still provide benefits there, depending on the landscape setting that they're in.
Okay, all right, thank you.
Also, ozark.wildlands.org. That's the local Ozark chapter of Wildlands. If you go to that website, we have a list of plant sources as well in this region, different native plant nurseries. So you just have to kind of see what the native plant nurseries have. But there are some watershed groups and nonprofits that have taken to growing their own plants, you know, especially the wetland species that might be not as suitable for a landscaping type environment. So.
Okay, great. Thank you for answering that. Sure. I'm going to get back to some of the questions here in the chat. And Quinn has a couple of questions too. So let me get to Jane's question here. She says they have a small wetland fed by a spring. It's filling up with horsetails. Is that a good thing or a bad thing? There used to be more plant diversity 10 years ago.
It's filling up with what now?
She wrote horsetails.
Horsetail, like the scouring rush, or yeah, like the other horsetail?
The scouring.
Yeah. Scouring rush?
Yes.
Okay. Yeah, I mean, I personally don't have a problem with scouring rush. I do know it has some benefits of phytoremediation. I couldn't tell you off the top of my head. I'd have to go look at my notes that I keep. But I mean, a lot of times you're going to see a succession of plant species anyway. And to me, that's a native species, although it did evolve. It's from an older type of native, you know, plant species that evolved before they were dependent on insects. So it might not be providing as much of the ecological benefits, but as far as like flood control and like slowing down water, whatnot, you know, horsetails, they can kind of grow thick in an area. And so that it does provide some of the more physical or mechanical benefits for slowing down and spreading out stormwater flow. But if it's along the edge of a pond, you know, that might not be as much of an issue. But I mean, personally, I'm not as concerned, but that's just my personal preference, you know.
Thank you.
Yep, definitely.
Thank
and
you,
it might
Eric.
still provide some thick shelter for other wildlife, you know, such as frogs or snakes, something like that too. So it's something else to consider.
Okay, thank you, Eric. Quinn, do you have a question?
I do. Hey, Eric.
Right.
Hey, Quinn, good to see you again.
Yeah. So I thought of this yesterday and, or the other day, and wanted to, just thought I'd ask tonight. So a lot of the plants that you mentioned that uptake, particularly the heavy metals, are seasonal plants, aren't they? They're grasses. And so wouldn't those heavy metals stay in the water? So the plants die, they either stay in the soil or drop to the bottom of the top of the surface of the bottom of the water.
Right.
And so they're there, and then the next generation has to take up that and any new heavy metals that come. And no pun intended, but isn't there going to be a saturation point at some time?
There probably would be, yes. Yeah, it's going to reach a point to where the biomass is not going to be able to take it all up. So, and typically when you want to use plants for extracting or remediating heavy metal contamination, at least in upland soils, you would harvest a plant and then take it and either compost it or incinerate it in a way that's safe or abides by local or state or federal regulations. But the point I'm just trying to make here is with some of these wetland detention ponds or stormwater detention ponds, until it reaches that point, it still is providing some of that benefit with preventing those heavy metals from getting past that containment area. And the solution might be to build some additional containment areas downstream or to expand that one.
And so my question was too, though, is there anything in the contract that requires that those plants be taken up seasonally?
I mean, that is one option that you could do, is harvest those, but you would want to make sure that you're not harvesting so much that they couldn't regrow, But yeah, that would be one way to continue to pull the heavy metals out of the water, is to then take a section of the biomass of those plants and then either compost or incinerate it in some way that's safe for the environment. Phyto mining is another name for being able to extract metals like this. There's been, I believe, I can't remember if it's chromium or nickel, but they've had a lot of success with some non-native species, brassica species, with pulling these heavy metals out of the soil. And then after they incinerate or compost off the other elements, they're left with that metal, and then they can then go through other processes, I'm sure, to make sure it's pure or how to get it to a certain level of purity and then reuse it. But phyto mining is kind of like this new phytotechnology, as it's called, to way to get heavy metals while also removing it from soil or contaminated soil.
But it's not a standard part of the contract that you would take up a 70% of the crop or reinstall it every year or anything like that.
I'm not aware, but I mean, that's not to say it couldn't be,
Yeah.
Yeah, I'm not aware of that necessarily being done. And I think phyto mining is a pretty new concept, and the one they've been doing a lot of research on, but I'm not sure how much of it has really been implemented in a more commercial or industrial type applications. But that's not to say that it's not something interesting, and start to think about how we might be able to use that in the future.
Yeah. Okay. Thanks.
Yep.
Thank
you.
Thank you, Quinn and Eric. But another question. This is from Geck, and it's about pond scum and algae. Is pond scum the same as algae? How much is too much algae? And could you tell us what the benefit of the algae is again?
Yeah, and when I say pond scum, it's just a generic term. I've heard people refer to all kinds of stuff, from algae to duckweed to anything green that floats on the surface. To a non-botanist, they think that, oh, it's just green scum, without seeing all the little detail in the plant. So I do want to make that distinction. And what I'm referring to, it's kind of just a general term with a negative connotation. But algae, the benefits it does provide is it is green, and it has chlorophyll in it. Through photosynthesis, combines H2O and carbon dioxide to create its carbohydrates, which is what it uses for its biomass. But then as a byproduct of that reaction, you get O2, which it then exhales. And then plants that are on land, they exhale this O2 into the air, and that's what we breathe, right? But plants that are submerged, they exhale that into the water, and so that O2 becomes dissolved within the water, and so that provides the oxygen that aquatic organisms like fish require in order to breathe. So some level of algae is needed, but when you have too much, it can also restrict the ability of light to get into the ecosystem, aquatic ecosystem, which can have other negative impacts. But it also, when it dies off at the end of the season, the microorganisms that decompose it, will consume a lot of the, or almost all, if not all, of the dissolved oxygen in the water, leaving none behind for the aquatic organisms such as fish to breathe, and so the fish die off because they suffocate.
Excuse me.
Thank you.
Eric.
Thank you.
Thank you.
Okay, I have another question. This is from Ava. With edible native plants like cattails with roots that can be made into flour, should a person worry about heavy metals that are stored in them if they were to eat them?
Definitely, yes. That is also an issue with lead plants as well, because it does also have some medicinal properties, and a lot of plants accumulate these heavy metals. And I'm becoming more and more, just as a person, I like foraging myself and eating wild edibles. And the more I learn about phytoremediation and what are called hyperaccumulators of heavy metals, the more I'm learning that some of these plants, you have to be very careful about where you're gathering them from. A lot of these heavy metals might not have been as prevalent or as mobile in our environment as, back 100 or 200 years ago. I mean, you think about leaded gasoline before it was banned. They say a lot of old roadside ditches that have been around back when leaded gasoline was in use are usually contaminated with lead, and so species like goldenrod, which often grow along these ditches and can be harvested for medicinal value, especially in the roots where that lead will accumulate. You might be, if you make tea with that, getting a dose of lead. So yeah, I definitely think it's an issue for us foragers to make sure we have to be aware of where we're gathering from, but be aware that it's not the same cattail roots that our great grandparents were harvesting. So there is a, and it may be too that, you're more going to have adverse impacts to your health if you're consuming it, long-term on a regular basis. Say, you might be able to get away with, a little bit here and there, depending on the level of toxicity. But I mean, it's kind of a shot in the dark as far as what you're getting sometimes.
Okay, thank you for answering that. Appreciate
Yes.
it. I have another question about, we started the talk this evening that, wetlands kind of used to be considered a wasteland, not beneficial. At what point did people, start realizing that, they were beneficial, and how did they discover that, and when?
Well, I mean, a lot of the public understanding of the benefits of wetlands has really taken off just in the last several decades with the Clean Water Act. But of course, there was, in the scientific community, they were, had a level of understanding of what the benefits of clean water and wetlands and, clean streams were. The issue that we had for a long time in the first half of the 20th century and the last part of the 19th century, where a lot of our rivers were so polluted, they were flammable. And so river fires are actually a thing that occurred on occasion in the first half of the 20th century and the last part of the 19th century. So like the Cuyahoga or whatever, I can't remember the name, that river fire. I mean, there was usually loss of life and loss of property involved in trying to put these things out. And so that led to a lot of the first attempts at regulating water pollution. And then and Jody will go more into this, I'm sure, during her talk, so I don't want to pull too much away from that. But I think since the Clean Water Act, a lot of these regulations, and then a lot of the environmental movement in the 70s and 80s has really done a lot to educate the public, to help disseminate that scientific knowledge and, to the public on what the benefits of these ecosystems are beyond just ecologically. And then also the more public knowledge you get, the more interest there is, and then it's easier to fund research. So it really has this interplay between those two. It's just, you end up getting like the Society of Wetland Scientists, and we publish a journal has published wetland research that, it's part of the people that are involved in the academic community, but we provide that resource, for wetland research and scientific publication.
Oh, thank you. Yeah, it's kind of like a domino effect, and then,
Yeah.
passes on down. Thank you.
Yeah, it's like a feedback loop.
Yeah, it is. You mentioned Jody's talk next week. I was just going to take this time to promote her talk on the 11th, Jody Murray Burns of Cattails Environmental is going to be here next Tuesday, same time, 6 o'clock, for the second installment of the American Wetland series. And she's going to be talking about wetlands regulation and the Clean Water Act. And then the following Tuesday, on May 18th, Dr. Faye Smith will be here to discuss wetlands and climate change. So, but the 3 different topics on 3 different evenings. So if you haven't already signed up for those, please, go onto our website and register for those and join in to learn more about American wetlands. I do have another question in the chat for you, and we'll have this be the last question. How can you get more information about an eco tour?
Well, Googling it, they're a little more common. South Louisiana, I mean, there's places that offer guided tours, kayak tours of some of the wetlands out there. If you own your own kayak, there's places like the Bell Slough Wildlife Management Area that you can just go out into your own. Like I said, Jody Murray Burns and myself, we've been organizing these eco tours here recently to help, as not just to educate the public, but these are also fundraisers for our local South Central chapter of the Society of Wetland Scientists. And just if you follow us on Facebook, or reach out, and I can keep you on an email list, or I'm sure Jody could too, to let you know if and when we are able to organize another one. But as far as elsewhere, I mean, you can check the Society of Wetland Scientists website, sws.org. Some of the ones that are happening around the country or in the South Central area covered by our chapter will often be posted on there. And like I said, there's other places that do these commercially as well.
Sounds like there's a lot of options out there. Yeah, for educational and entertainment tours in our area and beyond. So thank you. That's a lot of good information. I'm going to go ahead and wrap it up for us this evening. I want to thank you again, Eric, and thank you to those of you who were able to join us this evening. I hope to see you all again next week at our next session of the American
1 week from
Wetland
today.
That's right. That's right. Thank you, everyone. Have a
Thanks,
good night.
everybody.
Thank you.